I'm part of Rakuten Symphony pre-sales team, which deals in APAC region for our open products, which includes different portfolio. Just I can quickly brief you about Rakuten, so that if people whoever joined today don't know about the Rakuten and what they are doing in the Open RAN, they might be familiar with the Rakuten work. And so these are the agenda I categorized here for this session. So we are going to understand the requirement of radio planning, why it is important, and why good planning is key of success. And then we jump on next agenda, where we are going to see the ORN deployment planning. So there are certain things you need to plan. You need to design and plan for open deployment. That start from the transport planning. You need to figure out where the transport, whether it is provided by the MNO or operators, or you are going to lease it. So that you need to plan. You need to plan your aggregation routers and all the switches, and based on that you are going to design your DU, distributed unit. So this is if the people are join and they don't know about the Open RAN, then I might explain in the coming slide that the architecture which we used to have in Open RAN is now that used to be in traditional RAN is now in Open RAN is distributed. So we are having, instead of one DBU, we are having DU, DU and different CU, and that CU further divided into the CUCP and CUP instances. So there are three part now: RU, DU, and CU. Okay. So but the main point is we need to plan that the DU location very carefully, because DU run the real time applications. Okay, whatever use cases, let's say if talk about the 5G use cases, URLCC, or any other latency sensitive cases which run or which require real time processing. So that need to be carefully planned. So that's why we are going to see how we are going to design our DU, whether it should be distributed or centralized. Then you need to plan the hardware, right? That all the DU or all the workload need to be instantiated on underlying hardware. So we are going to see which hardware we are going to plan for the Open RAN, and where we are going to put those hardwares. So those hardwares you need to put in a data center, right? Those data centers could be a CDC, centralized data center, or regional data center, which is called RDC, or you can call ACE data center, or city pops, small pops, city pops, district pops, or for private network concept, we are also having one on-prem data centers. So you need to plan those data center based on the requirement. So that we are going to see in the network ORAN network planning and design. And in the last section, we are going to see the key parameter for radio planning, right? So let's start with the things, our session. As I told you, I will give you a little bit information about the Rakuten if someone who joined this call and don't know about the Rakuten. So we are geographical. We have geographical presence in multiple countries. You can see here. So we have presence in Americas, US, Germany, Middle East, and Africa, India, APAC, and Japan is our headquarter. So we have 1,500 uh, people in the R&D, and obviously in sales and operation there are other numbers, but for R&D we have more than 1,500 people, and we have partners 15 plus. We engage with the telcos as well as government and enterprises for the private network deployments. And our strategy is to build the product, partner with our ORAN ecosystem partners, and also we acquire some of the big companies to build our portfolio. So there was Innovi who was dealing with the OSS and BSS product, So Rakuten acquired this Innovi for BSS and OSS portfolio, and then Altiostar was for the ORAN. Uh, so now it is part of Rakuten, and we are getting ORAN from the Altiostar. Robin.io is mainly dealing with cloud platforms, SaaS platforms. So Rakuten is now part of. Sorry, Robin.io is now part of Rakuten, and ISMOB is mainly deal with the Internet of Things. So ISMOB is also part of this. So together we have made one portfolio which have the ORAN cloud platform, the OSS and BSS platform, and the internet services. And you can see we have partnered with multiple vendors like Cisco, NEC, Quanta, Nokia, SPAN, Intel, Qualcomm, F5. Why Symphony? Because that you need to know, we are different from other OEMs because we have unique vision, and we have bold ambition to execute our promises to the industry, and we have innovative culture because we have our own product which are different from the product which are available currently. Like we have SimWare in the DU, which is outdoor and don't require any cooling systems, and it has much bigger capacity with the updated versions. It have inbuilt switches, ASR routers, and other timing clocks. So it earlier we need to have the different ASR, different clocks, but this DU is inbuilt with everything. So that is what we have introduced with different models and the product, and that all these are recognized by different organization. You can see it in the slide. We have received multiple recognition from different bodies. Right. So this is all about our Rakuten and what we are doing for the Open RAN. Now we can start the radio planning. First, we start with the what is radio planning and why it is important. Initially important to plan a good network. That is a pillar of a good revenue, which allow resiliency, which give you the efficient network performance, and which makes room for the scalability. If you want to scale your network, and if you have well planned your network, then let's say uh, in the next 2 or 3 years, your network is going to your network is overloaded. So if you have planned very well, then you can scale up vertically or horizontally. Vertically means you can scale up the number of server, you can increase the number of server, or horizontally means you can increase the applications on that servers. So both is possible if you have planned your network very efficiently, and performance wise it will be efficient because you have considered all the parameter very correctly. You did the good simulation, you discuss with your team. So overall it was efficient planning, so that's why the network performance is going to be flawless. Resiliency is going to be there, cost effective, because you don't need to do many iteration to change the parameter, to change the plan, because the first was your the good and refined plan. So that is going to be cost effective, right? Because if you're going to do many iteration, that is going to be added cost. And if everything is good, your KPIs, your SLA is going to be improved, right? So everyone should be agree with this, that if you're planning and your network planning is good, then your KPIs, your SLA is going to meet, and definitely your SLA is going to be improved. So while you're planning, please make sure, guys, that you need to plan you need to design and you need to plan a agile network, because uh, with Open RAN, obviously the network architecture which you are going to plan is open, and what I mean by the open, it means any third party vendors can be integrated in the Open RAN. Okay, we can follow different split architecture. We are not like for the Open RAN, especially we are not like we are going to have everything in the site, and obviously that is not cost effective. So we are going to follow 3GPP and ORAN Alliance, all the split options. So mainly 7.2x is for ORAN, and option 2 is mainly we follow for small cells. Also, you need to plan very carefully, as I told you in the agenda slide, that DUC location is very efficient. Why? Because the location is so there is two options. First is you can put DU on site. Okay, the radio and DU could be on site. And the second option is you can put DU on centralized location. But you need to think, if you are going to get, or you are willing to get stringent latency or very low latency for latency sensitive application, then you have to put DU on the site. Otherwise, those real-time application would not give you the low latencies, right? But the resource utilization wise, if you're putting your DU on centralized location, maybe on city pops or district pops or is data center or RDC, that is going to be cost effective. But again, which use cases you can run? You can run like EMBB use cases if you are putting the DU in the data center. So that you need to take care while you are planning your network. And also you should be very careful while you're planning your data centers, because I told you different data center, district pops, city pops, and you cannot have like all the site in the city pops, because there is a limitation due to the power, due to the front haul bandwidth and front haul other factor. There is a capacity of each data center. Okay, and that capacity as well as distance. So what distance could be there from the data center to the site? So that you have to obey, and you have to follow that rule. So that we are going to discuss in the coming slide. And also, if you're planning, you have planned the agile network, your architecture will be end-to-end secure, which is good for the telcos. It is going to give you the flexible and agile built out due to the open and interoperable network. You are going to get autonomous self-healing functionality from the orchestrator, which we are going to use in the Open RAN, and you are going to see the scalable architecture, right? So this is the things which we need to take care while planning the ORAN network. Now let's see. As I told you in the introduction slide, that for especially for ORAN deployment, there are certain things which you need to follow. So we are going to see one by one. First, we'll start with the transport, because transport is first thing which you need to plan to start your planning. So the first thing is your mid haul and front haul requirement. So to understand where is the mid haul, if you are new for this split architecture, open LAN architecture, so the front haul is from your site where you have hosted your radio to DU or virtualized DU. So this interface is called front haul interface. From DU to CU, we have mid haul interface, and from CU to your core, that called backhaul interface. All right. So that you need to mind carefully, and based on this, you're going to plan your transport. So let's say what latency you required, because transport planning is mainly based on the latency requirement. Okay. So let's see for front haul latency budget. This is one way, not the round trip. This is one way. What latency budget is required? So for LTE guys, Open RAN, it is required less than 100 microsecond. So to get this latency, you have to think which front haul you are going to use. Obviously, you cannot fulfill this latency requirement through microwave, right? So you have to plan a fiber a kind of dark fiber which can fulfill your requirement. All right. So you need to think here. You cannot. You have to calculate the distance as well. What distance you can. Leverage to get this. I mean, you should be within this latency, and you can also have some bigger distance. All right, because that is also that always cost effective if you're covering the long distance. So you need to plan accordingly. For 5G, for sub 6 gigahertz frequency range in Open RAN, the latency is again less than 100 microsecond, right? So accordingly, we will plan this. So this is a 4G and this is for 5G. For mid haul here, from DU to CU, it is less than 25 milliseconds. So this is a millisecond and here is a microsecond. So you can see in mid haul we have a very relaxed latency requirement. All right. What it means? It means the distance from DU to CU can be more. All right. In rough calculation, that distance is depend on many factors like uh, what MIMO scheme you are using, what power per antenna port you are going to use. So that all calculate uh, and contribute in this distance. And roughly it is like 100 kilometers you can achieve in the mid haul. Roughly in the normal circumstances, 100 kilometer in the mid haul you can do. So you can put VDU and 100 kilometer away VCU. All right, but here for front haul it is very less because the latency is in microsecond. So accordingly you will be planning your transport network. What aggregation router is required, what L2 switches is required, what L3 switches is required. You need to plan very carefully according to your base station, and then you will go to the DU design. All right, now the very critical part, DU design. So you are going to see distributed and centralized. So what you are going to see, this is one option, and maybe minimize. All right. So this is one option I wanted to show you to understand the location planning based on your transport. Okay. So let's start with this side, right inside. This is CDC. CDC is your centralized data center where usually you host your OSS and core instances. Uh, in the RDC, you will be having your maybe VCU or RIC. So RIC is in from Open RAN. Okay, so this you can have in the RDC. All right. Again, through the transport, you can plan different edge data centers, or you can have the DU on the site. So let's start with the first option where you are having the DU on data center. So this option. Okay. So site, and we have the RU on the site, and this site is connected to the fiber front haul, and DU and data center. This is called for as centralized RAN data center. Okay, because the operator have fiber transport, and they have provided you the fiber transport, so you can plan your for better efficiency and better resource utilization. You can plan your DU in data center, right? So you have planned here. That is good. The second option is if that operator don't have that much of fiber capability, all right, and maybe that latency, the minimum latency which you required for LTE and 5G cannot be fulfilled by that operator, then you have to think DU on site option. So in this option, you are going to host DU on the site poles, all right? So that DU generally we use outdoor DU, means you don't require any air conditioner on the site to hold this DU. So it should be air cooled. You can install on the site, and further you can connect this DU through the mid haul, which have a very relaxed latency around 25 milliseconds. So you can easily use any fiber available with the your operator for which you are working, and then finally you can connect the RDC and CDC, yeah, through transport. The next option is for distributed RAN, and you have the DU on site, but you can also use microwave backhauls. Okay, if let's say if the fiber is not available with the operator, so you can also use microwave backhaul. But the condition is you that microwave backhaul need to meet 25 millisecond of latency, and there are some microwave vendors product which are offering this around this 25 millisecond of latency, and that can be useful in this type of deployment. All right, so this option you can use for very remote location or very any hilly areas where the fiber cannot be possible. All right, fiber cannot be laid down, so you can use the microwave in that case. The another option you can see here, so these are the D1 site option, but for ORAN, please make sure there is one more thing which you need to take care. That is timing. Okay, because timing is very sensitive in the ORAN. So you have to plan. There are three classes, actually four, but three is main. LLS C1, okay, LLS C2, and LLS C3, which define that the PTP and SYNC, which is required for synchronization of DU and RU is getting from which node. Okay, so you need to generate the grandmaster. All right, and that grandmaster need to be distributed to the boundary clock. So you have to plan which device, or you need to install a separate device for the timing clock, like a small timing router with a GPS to get this. Or there could be a DU which is timing aware, like the Symphony DU, which we have, which is called Symbiar, which is that is timing aware. So you don't need to deploy any separate aggregator or ASR router or any timing clock. The DU is self-sufficient to provide timing as well as the routing. So that you need to plan, you need to think. All right, so these are overall picture. Once you plan the transport, how you are going to plan your DUs. Let's move to the next part, that is the hardware planning. All right, so you are done with the transport planning and the CU DU location. Okay, one more thing I just forget here. So we discussed everything on the DU, but what about the CU? So CU, guys, always this should be in the centralized location, because the CU can run on the simple server. It don't require any accelerator card or anything. So it should be in the centralized. Then only the resources of the server can be utilized in most efficient way. So there is always I mean, in each case, in each scenario, whether the DU on site or DU on the edge, CU will be on the data center. All right, and try to keep CU on different data center from the DU. Okay, like here DU is in far edge, but the CU is in the RDC or in the district POPs, because then only you can leverage this. You can see the same CU is connected with this DU, this DU, this DU, and this DU. There are 4 DUs, but one CU is connected, because we are using the resources of the CU in most effective way. If you put this CU, sorry, let me go back. If you put this CU on this edge data center, okay, what will happen? You cannot use this CU resources. Let's say this CU you have installed here. Now, can you connect this sites, this DUs, to this CU? No, because you don't have direct connectivity with this Forest DC. So you have to put one another data CU for these two scenarios, right? So that is why we always put DC in a bigger scope of data center, so that it can host multiple DUs and resources can be utilized in most effective way, right? As far as CUCP and CUP is concerned, all right. So that all depend on the use cases which you are willing to deploy. If you are willing to deploy latency stringent use cases, then CUP should be nearby your site. Okay. If you are only going with the EMBB and this fixed wireless access, IoT, private LTE kind of things, then the CUCP and UP can be in the same place. There is no issue. Okay. So what it mean in summary, it means as long as you fulfill the latency requirement defined by the F1 interface. F1 means your middle interface, and the E1 interface, which is there in the between the CUCP and CUP. Okay. If you're fulfilling that, you can deploy anywhere in RDC or in CDC or in forest center. But the benefit you have to keep in mind, because as I told you, if you are putting this CU in here, you cannot use the CU's resources to these DU. So that you need to keep in mind while you're planning your network. I hope I'm clear here. We can move to the next part. There is hardware planning. So always plan hardware based on the requirement, and that should be I mean, obviously you will get input from your customer that they are willing to have the backup servers, or what storage they are looking at, and that storage all depend on uh, what what PM and FM the logs which they are storing, what duration they are going to be stored. Okay, if you're going to store those logs for the longer time, then obviously storage is going to be increased. So based on those input, you are going to plan your servers, data, storage servers, and computation servers. So there are two type of server. One is a compute server and a storage server. Storage cannot host your cloud network and OSS instances. Okay, because storage is just only for storing your data. Okay, that is also important, but for hosting those instances, this workload, you require a compute servers. So this is a stack we need to follow for end-to-end planning. First of all, this is the stack in Rakuten we are also following. That first we start with the server. Okay, server you have deployed, then you are going to instantiate those server with the OS, host OS. Obviously, let's say if there is a laptop in laptop you cannot run Microsoft Office without installing the OS, operating system. So the same thing is here. Server cannot run for the application without installing the OS. So you have to install first the host OS, and then the Kubernetes environments. So Kubernetes environments you are going to install, and that for that there is multiple vendors in the market. There is from Rakuten we have the Robin.io. You can use AWS, you can use Google platforms for Kubernetes. There are many more. VMware is there, so that you are going to use for the orchestration. Okay, and once your platform is ready, so this is a platform. Once your platform is ready, now you can host your workloads. Okay, workloads means your eNodeBs, video, LT videos, or LT DUs, or RIC, or LTCUs, or NRCUs. Okay, or SON, self-organizing network workloads, or the core workload, or the DUs, Symbiar or RU plus DU configuration, or RU plus DU plus U configuration. So anything you can load once your platform is ready. Okay. So let's say your platform is ready. You hosted all the network functions here from the RAN and from the core. Now, the third option is you have to manage those network workloads, right? Because you deployed your things, and if you're not managing those things, then it is a waste, right? You have to manage those things. So managing those workloads is done through our SimWorld. Okay, so for Rakuten we have SimWorld, uh, which is kind of OSS. In normal terminology, you can call the combination of OSS, EMS, BSS, AIML, orchestration, okay, and the cloud. It's all included in the SimWorld. So we need to deploy our OSS workload to manage the cloud and the network. Okay, so this is what we required for end-to-end planning, and you have to make sure that you are going to follow these steps. If you talk about the Rakuten advantages in deployment of these, so whatever we are deploying, that is first of all COTS hardware. It means it is x86 Intel based x86 hardwares. Okay, it's cost based hardwares. Uh, it is elasticity is there with the container to scale at the lower cost, means you can scale it whenever there is more resources required. You need to increase the uh, servers, so that you can easily do. What Rakuten advantage is there with the network functions. So our network function is 100% disaggregated from the hardware. So we don't bother which hardware you are going to deploy. We can host our workloads, our eNode Bs, DU, CU, RIC, SON, core, anything on any hardware. The only condition is it should be a GPP, general processor, uh, x86 based COTS hardware, COTS hardwares or servers. The only thing is matter. You can use from any companies, whether it's from Supermicro, from HP, from Dell, any hardware you can bring. We can host our network functions on those hardwares because we are 100% disaggregated from the hardware, and we follow the open architecture, means any third party can be integrated in our system. The next advantage from the operation from the Rakuten point of view is we provide advanced automation for touchless operation. What it mean in the simple language, you are sending someone to the site for installation of the site, and once installation is done, what you need to do, you need to switch on and configure, run certain script in the site to to bring that site power on. But in our scenario, it's a touchless, and the operation called zero touch provisioning, means there is no manual intervention is required to instantiate or on air the site. Just you sit in the NOC in the remote location. Okay, the power on, you don't need to send anyone to the power on the switch. It will be triggered from the NOC. You can power on from the NOC. You can self configure anything, the network files in the eNode B without any manual intervention, or without sending any engineer or technician on the site. So obviously that is cost effective. So that is what we are getting from the advanced automation. So let's and understand the hardware point of view. So this is a cloud, and I told you you have to fix first the platform, the cloud platform. So we are planning the servers. Uh, that could be, as I told you, it could be a GPP. It should be a GPP server, x86 COTS based. and it could be Supermicro, Dell, HP, or anyone, right? Once you plan the server, also while you're planning, you have to dimension your resources. Okay, just one minute. You have to dimension your resources. What I mean by saying the dimensioning, dimensioning means, let's say there is one customer who required only 3 cells for their deployment. Okay, so how many P cores? So there is a dimensioning from the from each core and vendors, that how many P core, physical core, because these servers are going to give you the cores, physical core or virtual cores. So how many physical cores are required to host these 3 cells? Let's say if there is another customer who is going to give you 6 cells, and there is 2 carrier with those with that operator. So you need to plan your so obviously the P core count is going to be increased. So based on the P core counts, you are going to plan the resources for the server. Okay, one server with a single socket usually give you 32 cores. How many cores? It is 32 cores, P cores. Now, let's say there is one customer who might have who might need to instantiate 9 cells. Okay, 9 cells with the heavy configuration. Heavy configuration means they need to deploy massive MIMO, not the simple 2x2 MIMO or 4x4 MIMO. They are looking at massive MIMO things. So that all leads to heavier configuration with the more number of P core requirement. Okay, so if the P core requirement, just example, is 20 or 25, what it mean? It means one single socket server give you 32 cores, and you are requiring only 20-25. It means only one server is required to host that many of sites. Okay, this 20 to 25 is not for the one site. Okay, remember, in ORAN, ORAN is based than the traditional. The one reason is we are we require very less resources to run one inode B. For example, in traditional, one site require one inode B setup, but in ORAN, and especially in virtualized ORAN, even one server, okay, this one server can host 9 inode B or gnode Bs. Okay, not one, it can host 9. So it's very much cost effective. So that is why I'm telling you, based on the resource calculation, you can calculate your number of servers. Okay, once number of servers has been calculated, you can you can figure out which hardware radio is going to be used based on the frequencies. So these are the vendors which are part of ORAN ecosystem. So like MTI is there, Comba is there, Prose is there, Fujitsu is there, Sercom, Airspan, and there are many more. Who is uh, having the radios in this open, making the radios for the open RAN. So you can, based on your frequency requirement, let's say the frequency requirement is a B8, band 8, okay, or N78. There's sub-6 frequency for 5G. So you need to think, you need to look which vendor is providing those radios, okay, and then you can select those vendor. So your server hardware requirement is fulfilled by taking care of the resources. Your radio hardware is done based on the frequency you have selected, frequency and the MIMO scheme, which is requested by the operator. Okay, now the next one is a software cloud planning. So you can choose Rakuten Robin.io, or you can choose AWS, you can choose VMware, or anyone you can choose for this orchestration. Now your platform is ready. Next, what you are going to do? You are going to plan your you are going to perform your dimensioning on resource planning, as I told you here, that with how many cores is required to host those servers. Server is already planned, a radio is already planned. Now you need to calculate how many resources you required for the DU, how many resources you required for the CU, how many resources you require for the RIC, how many resources you require for the zone and core. And based on that, you are going to calculate that how many server you require to host in a data center. Obviously, you need to already get the input from your operator that how many backup server they are looking at, and what is their plan to have a backup server. Okay, usually for ORAN, we plan around for 25 servers, we plan one backup server. Why that much less? Why we are not planning 1+1? The workload what we are deploying is based on the Kubernetes. It's a Kubernetes environment, Kubernetes based network functions. It means we are going to get inbuilt Kubernetes functionality, kind of self-healing. Okay, what it mean? It means if any workload is got errored or failed, it will automatically instantiate it in different location on the same server. So that we are already going to get. And also for each microservice there is a 3 or 4 copy. Always it's active. So if one got failed, 2 is running. Okay, so your operation is not going to harm. So that is why we are considering very less backup servers. It's around 25 to 30 servers for one backup server, due to this reason, because the environment which we are using is kind of self-healing, and the macro services which we are using here is going to provide active plus active scenario. Okay, that is 3 or 4 work instances running at the same time for each microservices. Okay, so that is all about your hardware and software planning for network functions. The next part is your OSS. Okay, so hardware is again same hardware. If you see here, the hardwares are not changing. What it means, any workload, whether it's a CU, your eNodeB CO, eNodeB DU, or core or RIC or SON or any other workload, our servers is not going to change. That what it means? It means same server can be used to host any applications, whether it's OSS application or any eNodeB application or core application, or any SON or any other third-party applications. Same servers can be used. And obviously for OSS and EMS, you have to perform the dimensioning. It is same like what we did for eNodeB and gNodeB. Right? How many cell site you need to manage through that EMS. Let's say if the customer is saying, I need to manage 10,000 site. I am going to deploy 10,000 site, and you need to plan, you need to manage all those sites, and you have to plan how many EMS or OSS you are going to deploy, to keep in mind that those servers is going to provide a high level capability. Okay, high level environment, it means it should have the geographic redundancy. I mean, in one location, if the server got failed, the other location servers can immediately power on and up and running. So based on those input, we plan that how many location and geographic locations we are going to plan these management servers, and based on that, we are going to dimension our resources and figure out that how many servers you required for this OSS and EMS. Okay, and obviously, if customer is looking at more automation should, so if they are looking at zero touch provisioning, so obviously that requires some additional resources. If they are looking at AI/ML, advanced analytics, then obviously they need to spend more number of PCores. So that lead to more number of servers. So based on that, you will be planning your servers for the data center. Now you have planned your transmission, you have planned your DU, whether it should be distributed or centralized. The next thing you have planned that which server you are going to use, which radios you are going to use, which software for network functions you are going to use, which management uh, you are going to use, and you're going to use on which server. The next thing is data center planning, right? So you have to think that which network data center. I mean, how many data center you are going to plan. So, for example, to host these instances, as I told you, these are part of our architecture. Uh, in traditional, everything was on the site with the and that was called BBU, baseband unit. But now we have we have distributed this with the VDU, VCU, all right, and there is RU on the site. To host this video and CO, you can plan these many of data centers. So first one on-prem is especially for private network. So private network is very much in talk in telecom because this is a hot topic in today's conversation, because every OEM wanted to host this private network. If you'll ask me the reason in brief, the main reason in common and the advantage is this on-prem private network is going to give you the same kind of operation like a telco grade network give you, but in the secure environment, because now the core everything core eNodeB and any other management application, all is going to be inside that enterprise location. Okay, like if it is a mining field, then everything will be on the site. So your data is not going to be leak or trapped from outside, because it will be confined in one location, and that resources cannot be shared publicly. It will be all inside that location. So that is why the MNOs are preferring this private network. So for that, you need a on-prem data center. These are for the normal telco grid deployments. So there could be a city pops, district pops, RDC, and CDC. City pop, you can understand if there is one city, and in city you will be planning this city pops. So small data centers. So that will be a simple 19-inch rack inside the data center. So you will be having one shelter. Inside the shelter, you will be having the multiple racks, and those racks, how you are going to calculate how many racks you require. That is depend on your dimensioning. What you did here, the dimensioning for OSS, dimensioning for your network functions, and based on the dimensioning, you have calculated already the number of servers. Okay. Now each rack had their capability based on their power, based on the power which they can offer for the servers, and each server consume a power, a defined power. Okay, let's say if certain load, 100% or 60% load, one server is consuming, let's say 500 watt power, and total power for one rack is 10 kilowatt. So based on that, you can calculate how many servers. So you can, and also the height unit of servers. So maybe you can have 10 to 15 servers in one rack. Okay, so 10 to 15 servers in one rack, and let's say you required 100 servers. So based on that, you can plan how many racks you required in city pops. Okay, this is an example. City POPs is very limited, very small data center, because the location between sites to city POPs, due to the front haul latency requirement, and it should be very less. Okay, so and mainly in city POPs we are going to deploy DUs. These are runtime, and DUs are running with the runtime applications. So latency is very much factor here. So very less sites we are going to have. So let's say the distance of the site from the city POPs usually should not be more than 10 kilometers. So you can consider in one city, there could be multiple city POPs. And those city POPs is finally going to connect with the district POPs. So district POP, usually we are using for to host in some cases the DU, and in some cases CUs. Okay, based on the customer use cases requirement. Okay, if there is a certain use cases like FWA, fixed wireless access, in that certain cluster or certain area, so that don't require the very stringent latency. So we can plan our we can have or host our DU on district POP as well. Okay, so that is how we are planning the different data centers. So you will calculate again how many servers are required, how many power cables are required, how many power is required, and based on that you will be calculating your number of racks that will be installed in the data center. And the RDC generally hosts your SON application, RIC application, and CU applications. And CDC is for your IMS, core, or management applications. Okay, so you need to plan your data center based on this input, and how you will check which rack you are going to use in this data center. So there is slide. Okay, just 1 minute. I will give you that. So this is an example I want to show you to you guys, that this is how the racks will look like, and these racks is going to be going to be installed inside the data center. So these racks could be wheel based, or it could be fixed rack. That again you are going to decide. You need to discuss with the customer what is their preference, and you're going to decide the height unit. Let's say this server is 42 height unit. It is for 850 mm deep. So 850 mm is a general requirement, because all the servers with the GPP servers, COTS bit servers is having 850 mm deep requirement. So that we need to have. The dimensioning is here. What front we required, what back we required, so height, length, height, and the depth with wheel-based server or static servers that you need to plan. So you have your specification from your servers, and based on that you are going to plan your rack, total power required by the servers and the supported by the racks. Okay, the cable length, the number of servers fan flow, its front flow or back flow, because some servers uses this front flow option and some back flow option. So that you need to see, and accordingly you have to put your design your data center to put your rack. All right, so you done with the rack planning, you done with the data center planning. Now you can easily deploy your means you can easily design or plan your ORAN network. The next part is how you are going to plan your ORAN. So mainly we are going to discuss the radio planning. Okay, so there are some guys who already worked on the planning of radio networks for the traditional RAN, right? For ORAN radio point of view, there is almost no change we have observed. The changes which we have observed in that part, which I already explained you. So that's why in the radio planning, considering that the packs already have some experience in the planning, that's why they are attending this Oren planning session. So I have kept this information on very brief, just to refresh your knowledge that what key point we need to consider while planning on network. So we need to start with the process of radio planning. So there are 4 steps which need to plan, which you need to think. The first is dimensioning, then the nominal planning, then the detailed planning, and the pre-launch optimization. And the goal of planning is to calculate number of site to the location and the configuration, so that you can address the coverage and the required capacity. Okay, so to meet this, you are going to plan, you are going to follow this process. So through dimensioning, what you can calculate, then calculate the number of sites required to serve the certain area. So let's say customer uh, gave you uh, one uh, one area, one city area like this. So this is this is one area where you have maybe one big highway, and then there this pocket is dense urban pocket. There is some pocket with the urban area. There is some pocket with rural areas, and there is some pocket with the suburban areas. And together it make one cluster. So these are one cluster where you're going to plan your network. So you have to first get to know from the customer that what is the location. So location is must. And the second thing is, once you get the location, what would be the second thing? You have to you have to get a certain parameter from the customer, like what band they got from their regulatory body, right? What frequency band they need to deploy, what is the bandwidth going to use. Okay, so now you have to plan where you are going to host your sites. So here you are going to host your site, because we have not done the planning yet. We are just thinking where we can deploy our site, so that the area which is here, the big highway or the dense urban, the urban and the rural can be served. So obviously in the rural area you require less sites. In the dense urban you can more site. All right. So accordingly you have to think and plan. So what we are going to do, we are going to start with the dimensioning to calculate that how many sites would be required in that certain area. And once you decided that how many sites is required, then you are going to plan a nominal. Nominal means one location on multiple candidates, so that if one is not granted, I mean, if you not get that desired location, there should be multiple candidate, so that you can get uh, the site at the nearby location. Once nominal has been planned, the next one is detailed coverage planning. So for this coverage and capacity analysis, for this you have to perform site survey and the drive test. Okay, and then based on the drive test and then the site survey, you will be validating your nominal planning and changing your nominal planning. Okay, let's say the site survey is saying that the nominal which you have planned will not fulfill the desired coverage. There could be an area where coverage cannot be reached, so you have to change your nominal again. Once detail is final, nominal is final, you have calculated the number of sites. The next one is tune the site for the commercial launch through the physical and parameter optimization, because you are ready for the pre-launch optimization. You have installed the site, everything is there, site is on air. Now you have to fine tune the parameter for commercial launch, because pre-launch optimization is in our KRA. Means if you're working for planning for a company, then pre-launch optimization is in your KRA, in your area. When site is launched and accepted, then it will be managed by the operation guys. So fine tuning of the launch site should be done by the operation guys, but the pre-launch optimization is in our category. So you have to think very carefully that whatever sites you have calculated from the different dimensioning tools. So there is a tool or many other tools generally we use. So whatever tools you have used there, you have calculated the number of sites, but the site count can be derived from the radio planning, and sometimes significantly different from the site count derived from the dimensioning. So whatever planning you have figure out through the ATOL or any two other tools, and whatever planning you have calculated, whatever site you have calculated from the dimensioning, sometimes it's differ. So what you need to do, you need to perform this thing, this dimensioning again and again, and you need to change certain parameters, like if first time you have used any propagation model, let's say empirical model. So there is a three model generally we use: empirical, semi-empirical, and deterministic. So obviously deterministic is very well, it's feedback based, but let's say if you have used empirical model in the first planning, so maybe you can change that empirical model to the semi-empirical or deterministic, and you can get a realistic value through the planning. So that you have to already perform again and again to get the actual number of sites, so that the area which has been provided by the customer is fulfilled with the actual information and the correct information. Let's start with the coverage planning. Okay, I hope everyone is aware about this, the link budget planning. Okay, so the link budget is basis of coverage planning. We are going to calculate the uplink and downlink MAPL. MAPL is maximum allowed path loss, right? Once you get the MAPL, you can add the suitable propagation model. Okay, it could be from empirical model, you can use Okumura-Hata. From semi-empirical, you can use Welfis Ikegami, or from deterministic, you can use ray tracing. So any model you can use based on the clutter or the cluster, and once you add both, you can get a average cell coverage radius. And once you get the cell radius, means one cell radius, you can calculate total site area. Okay, there is a formula, and that formulas all based on how many sector you are going to deploy. If you are going to deploy 3 sector site, so that formula is different. If you are going to deploy 2 sector site, the formula is different. And if you're going to deploy omnidirectional antenna, then that formula will be different. I am going to show you in some time how this this formula is going to be to calculate your areas, site area, total site area. So once you calculate the site areas, you can even calculate how many number of site required in that total area, total cluster area. So one site area you require, and total area you already know. So once you derive this two information, you can calculate how many number of sites you require in that area. Okay, so that we are going to see. This is the flow or algo we use for the coverage dimensioning. So link budget, you already calculated. MAPL, maximum allowed path loss. Propagation model, okay, Welfis Ikegami or ray tracing or Okumura-Hata, anyone whichever is fulfilling the requirement which you desired in that location. You have calculated the cell radius and area per site. You already know that the total area is, let's say, customer has provided you 100-kilometer areas, 100-kilometer area, that hey, you need to plan the network for this 100-kilometer area, and you have calculated the area per site, area per cell per site is let's say one site can cover 10 kilometers. It's very hypothetical. 10 kilometer cannot be covered with one site, but I'm giving you the example, right? So let's say if one site is there is a rural environment, and one site can cover 10 kilometer. So how you will calculate number of site for the coverage? So the simple one, 100 divided by one site area, 10. What it mean? It means you required 10 sites in that area to cover your cluster. So this target area required how many sites? 10 sites. So you got your sites from dimensioning. Okay, so that dimensioning we were discussing, if you remember here. So this is the dimensioning we were discussing here. The next part is nominal planning. We will go to the nominal planning in later stage. First, we need to see dimensioning and their parameter. So we perform the coverage dimensioning. We will also look the capacity dimensioning, because you cannot figure out the final number from the coverage only. You have to think capacity as well. So we are going to see the capacity as well in some time. Let's see the parameter which you required for the coverage dimensioning. So first of all, there is MAPL, maximum allowed path loss. So there is simple formula for MAPL. The EIRP minus IRP. IRP is isotropic power requirement. Means the transmit power minus the receive signal power is MAPL. Now, what is EIRP? EIRP is the output power plus gains, and you need to subtract the losses in the margin. You can calculate your EIRP. So total transmit power, you can add the gains, antenna gains like 18 dBi antenna gain or 21 dBi antenna gain, whatever antenna you are using. If you're using 2 dB antenna for a small cell deployment, then you can add there. So all gains should be added in EIRP calculation, and the losses in the margin, like margin EM, interference margin. There is a gas margin. You need to subtract the connector loss, feederless solution, the cable loss, that you need to subtract, and you will get the EIRP. For IPR, this is a receiver part. So receiver sensitivity, and here you are going to subtract the gains, and you need to add the losses. So just different from what we did in the EIRP. EIRP, you have added the gains, but here you are going to subtract the adding the losses. So whether it's a building loss, body loss, interference margin, slow fading margin, or gain against shedding, this is gas. So that all you need to consider to calculate your MAPL. Hope it is clear to everyone. Now let's see the general parameter which affect the MAPL calculation. So main parameters are operating bandwidth, because different propagation loss, different bands. Higher bandwidth, higher operating band, higher loss. Lower frequency, low loss, and more distance, that you know already. So next part is channel bandwidth. Channel bandwidth, because it impact the factor such as thermal noise, overhead ratio, and total cell throughput. If you have a lower channel bandwidth, your throughput will be less, right? And it is also going to impact your thermal noise. The next is antenna gain, because gain changes your antenna type and frequency band. And if you have you can identify the antenna. If the antenna is small, okay, that means it is working on the higher frequency. So higher frequency, small antenna. Lower frequency, big antenna. So there is some visual identification I can tell you, and other gains like multi-antenna configuration, another that you need to consider. Propagation model, already told you the different propagation model: empirical, semi-empirical, deterministic, effect the MPL calculation. Also the floor noise, like thermal noise. So floor noise, how can calculate? It calculate you will thermal noise plus noise floor, right? So thermal noise is you can calculate basically through the one formula which is called KTV. K is Boltzmann constant, T is thermal temperature, B is bandwidth. You can calculate thermal noise, and noise figure is generally hardware values. So from A node B, the value is less. For transmitter side is less, and receiver side means the node B, the value is higher. Generally 3 dB for node Bs and 7 dB for UAs. So that there's a rough value. It can be depend on different OEMs. It can be changed. Interference margin is also factor which impact the MEPL calculation, because higher cell load means higher interference from the neighbor cells, and higher neighbor cell load increase the IM, that in terms of reduce the MEPL. So MEPL value will be reduced because IM you are going to add in the IPR. All right, you remember this here, the interference margin you are going to add to calculate the IPR. If this value is greater, then your final MEPL is going to reduce, right? So that is why the IMs are going to be reduced the MEPL. And building in penetration loss, body loss. So because indoor and outdoor, your losses can be increased building by building. So there are different type of building you need to consider. You need to see the what losses you are going to get from different kind of buildings, and you need to consider those values. And for body loss, typically 2 to 3 dB we observe for the VoIP, and for data it's 0 dB. Oh, the reason is for VoIP means voice call. You need to keep your phone like this, and the transmitter is close to your head. So there is some loss due to the obstruction from your hand. But if you're using your data, your mobile is in front, so there is no loss in the transmitter in the radio propagation. So that's why 0 dB loss we observe in the data user. And gas, usually gas correspond to the location probability. LP is location probability, differences from 70 to 75 percent. And according to Gaussian formula, gas can be there is a constant value into the, there's a lambda. Lambda is a static value of the Gaussian standard. So through this you can calculate your gas against CDV. There are some features which can also impact your MEPL calculation, like you are using less modulation schemes here. If you're using less modulation scheme, your coverage is going to increase. So that impact your MEPL. If you're going to use more number of receivers in the UE, that also means the data, the information can be reliable, but you have to transmit from the this port. So that is also going to impact your MEPL. Then if you're using closed loop MIMO or open loop MIMO or interference rejection combination features or downlink power boosting. So wherever due to the feature, if coverage is going to be changed, okay, that impact your MEPL calculation. So if you're considering those features, you need to consider the impact of those features in the MEPL. Otherwise, your calculation cannot be correct. All right, so you need to consider these features very carefully. The next thing is, let's say if you are planning for TDD resources. So what you need to think, because TDD is half duplex, and FDD is full duplex. So if you're planning TDD, you need to plan more resources than the FDD, correct? Because if you see example here, the previous was FDD resources. This is the FDD resource, okay? But to reach the resources, whatever you have get from this much of bandwidth, how much bandwidth you have to you need to have in TDD, that will be this, because in the same TTI you would have more bandwidth to get some amount of the resources or throughput from the TDD. So that you need to consider, because the transport block size is it's something which is factored this the formula. So you need to consider this. The final thing is in the coverage dimensioning, I have provided one example calculation. So I told you each companies have their own tools to calculate these number of sites. Okay, so this is the formula you need to make sure you are following to calculate your number of sites. Total area size, okay, total area size. These are the different environment, dense urban, urban, suburban, divided by the site area. Site area is this one. Now I told you that what formula you are going to use is all depend on the kind of sector you are using. So if you're using 3-sector area, so to calculate the site area from the cell radius, you need to use 1.95 R3. So it means R3 here, R3 is 0.21. So you can calculate for the tri-sector. For omni or 6-sector, the formula is 2.6 R1. R1 is again cell radius. Then you can calculate the site area, and when site area is obtained, then you can easily calculate the number of site, because total area divided by the site area. Site area is this. Okay, and total area is this. So 30 divided by this, you can get this. Now let's say if this is the cluster which I just explained in the whiteboard, that there is a highway and there is dense urban, urban, suburban, and rural, and you have to plan the site. So you have calculated the dimensioning, you have planned the nominal, you have done the detailed planning. Now you need to find how many sites finally you are getting from that cluster, including all the environment. So let's say if you have received 351 sites from dense urban, you have received 352, 77 from the suburban, and rural from 85. So together it will be 865. So 865 you required to serve the area which I just explained you, or any area which is provided by the customer. This is just example. Right? Hope it is clear to everyone. Just time check. It's 15 minutes only. So I will quickly run through this capacity dimensioning, guys. So for capacity dimensioning, the main thing is you need to get this part, the total user. So total user, you are going to get these numbers from maybe sometime with the customer, or you can get the historical value from the other operators, and this value you have already get. Now the next thing what you required is traffic model. Now the traffic model can be like voice dominant traffic. So that all depend on the customer choice. If they are going with the voice dominant traffic or data dominant traffic, or 50-50, they want to have a 50% domination from the voice resources, and for 50% dominance from the data resources, or they want 80% dominance from data or 20% from the voice. That all traffic model is provided by customer. You got the traffic model. Now you will calculate the traffic demand in the BHCA, busy hour. How many? So there is certain scenario, some calculation, some simulation you need to calculate to get the busy hour traffic demand. with the help of traffic model. It is based on the application modeling. Based on the certain application, you can calculate how many what traffic demand you are going to get per user during the busy hour. So that is very important. You need to calculate. So once you calculate this traffic demand in the busy hour, and you have already got the total user, you can easily calculate by dividing this two. You can easily calculate the total expected traffic. The area same we are discussing, which I just explained you. Now the next the part is capacity per site. Okay, so capacity per site is a calculation which you need to do. So there are a lot of things which you need to consider to calculate the capacity per site, like the operating band, the transmission per PRB, the antenna MIMO configuration, the layout, the scheduling type. So all you need to consider to calculate the capacity per site. And once you calculate the capacity per site, you already received the total expected traffic. Just calculate this, work with these two formulas, and then you can find just divide this total expected traffic divided by the total capacity per site. You can get number of site for the capacity. All right. So this is the called capacity dimensioning. Right. So that is what the main formula I have mentioned here. The same I explained in there. And remember, I told you the finding total number of site in certain area cannot be decided through one dimensioning, coverage or capacity. You have to calculate both, and finally, whichever will give you maximum number, that will be the final dimensioning output or number of site required. Let's say from traffic damage, from coverage dimensioning, you have received 1000 sites required in that area, and from capacity, let's say you have received 1200 sites. Okay, so which will be your final output? 1200, because the maximum you're going to select. And for nominal planning, you need to follow this steps, the process, like these are moreover manual thing, that what RF equipment you are using, antenna and gains and all, what frequency band using, clutter map you need to use, the customer data and services you need to use, the propagation model, antenna height and all you need to consider, the link budget, web propagation model and all you need to consider, and put everything, and the number of candidate I told you, and put all those in the planning tool, and you can see that you need to analyze the coverage and capacity and parameter analysis configuration, and then do the site survey. And then you will, if site survey is deviating from what you have planned here or what you have get here, then design the verification again, and then go to the final plan, that here I'm going to deploy the site. This is the location I'm going to choose for the final site deployment. So you have to do this. And if you ask me how you will get the simulation result from the tools, so that is how you can get the coverage area in the downlink scenario with a certain throughput. Like these are the site. The red one is the peak throughput, and the blue one on the green. This one is the throughput nearby this 15,000 kbps, and other areas. The blue one is very less throughput, like 1000 kbps. So that is what you can. That is how you can get. It's just for the simulation demo purpose from the simulation, and this uplink you can see that how many throughput you can get. Legends are here, so how many throughput you can get in that offered target area. All right, so there is it from my side from this presentation, guys. Now we can open for questions if you have.
Okay, so let me get some questions coming from Carlos Saul Perez. He said, hello, I have heard from technical colleagues about capacity planning, users, traffic model, throughput, and coverage planning, estimated coverage area. Don't we have that in the planning, or it's not considered today? I think it's an early question, so, but I think it's already covered by Abhishek.
Yes.
Okay. Uh-huh. In Oran architecture, where do you include the accelerator boards?
Okay, so accelerator cars are in DU because
DU.
DUs are very real-time sensitive. It run very real-time sensitive applications. So that accelerator card we usually have in the DU.
Carlos Saul Perez again. What are the tools that we could use for capacity planning and coverage planning? Are there any for free?
Maybe you can Google it if any free. I don't know about the free, but the Atoll is there, Randium is there. There are many which is used by the multiple OEMs and operators that I can answer, but I don't know about the free.
Yeah, most of the free are limited versions. It cannot do what Atoll or Mentum Planet can do. So
Yes, right.
if it's a professional or a corporate planning and designing, you need to purchase, including the maps, right? Okay. From Randy Vibal, how many capacity server in one rack? There have the switch and the aggregator top, and capacity of the server. How many hard disks?
Capacity of server, I explain you. There is two category, even three categories there. With single socket, there is 32 cores. Okay, and with dual socket it's 64 cores, but there is one when there is one vendor which provide 2U4N servers. It means one servers with four slices, each slice with 32 core, so together it will be 128 cores with one server. So it's very heavy server that we can also use. And for the rack, all the rack have their own capacity. Some rack offer 8 kilowatt power, some rack offer 12 kilowatt, some rack offer 10 kilowatt and 12 kilowatt. So, and one server required around 500 to 800 watt power in 80% of load. So you can calculate, it's a mathematic formula. One server 500 to 800 watt, and one rack can give you total 10 kVA. So you can calculate how many server you can host in one rack.
Okay, there's a follow-up question on this, Abhishek. Does many core means users?
No, cores is a resource of servers. So whatever servers we are going to use, GPP servers, they offer the resources in terms of cores. So that could be that is physical core, and it can be converted into virtual core as well.
Okay, got it. Okay.